4 miles off the coast of Santorini, directly beneath the calm blue surface of the Mediterranean, a massive magma chamber has been growing for nearly 400 years. No eruption, no smoke, just pressure building in the dark. Scientists only confirmed its true size recently, and what they found is forcing a serious reassessment of volcanic risk in the region. This is the Kolumbo volcano, a submarine volcano located just 7 kilometers from one of the most visited islands on Earth. And what is happening beneath it is not ancient history. It is an active geological system evolving right now. When most people picture a volcano, they imagine a mountain with lava pouring down its sides. But most of Earth's volcanoes are underwater, hidden, difficult to monitor, and capable of highly explosive eruptions. Kolumbo sits about 1,600 feet, 500 meters, below the sea surface along the Hellenic volcanic arc, the same tectonic boundary that produced the eruption of Thera around 1600 BCE, one of the largest eruptions in human history, and an event that devastated the Minoan civilization. The last time Kolumbo erupted was in 1650. Pyroclastic flows moved across the sea surface and reached Santorini. Toxic gases spread across the island. 70 people died. For that era, it was a catastrophic event. Then the volcano went silent for almost 4 centuries. But volcanic silence does not mean inactivity. In many cases, it means magma is accumulating out of sight. And that is exactly what scientists discovered. Beneath the seafloor, Kolumbo had been building a substantial magma chamber that traditional monitoring techniques had not clearly identified. When researchers finally imaged the subsurface, the data were striking. Kolumbo is part of a volcanic field containing at least 25 submarine cones aligned northeast of Santorini. This region sits where the African plate subducts beneath the Aegean plate, creating ideal conditions for sustained magma generation. For years, scientists asked how much magma was stored beneath Kolumbo. The answer was larger than expected. In October 2022, a study published in Geochemistry, Geophysics. Geosystems used full waveform inversion, an advanced seismic imaging technique comparable to medical ultrasound, to create a detailed image of the volcano's interior. Researchers transmitted acoustic waves through the ocean floor. The waves traveled quickly through solid rock but slowed significantly when passing through molten material. By analyzing those differences, they constructed a 3-dimensional image of the magma system. The imaging revealed a previously unknown magma chamber extending roughly 2 to 4 kilometers, about 1.25 to 2.5 miles, beneath sea level and spanning approximately 600 meters across. The estimated magma volume is about 1.4 cubic kilometers. To put that into perspective, imagine carving a cube of molten rock nearly a kilometer wide on every side, hot enough to melt steel, hidden beneath the seafloor. Or picture a mass of magma large enough to bury Manhattan hundreds of feet deep. That is the scale we are talking about. More significant than the size is the growth rate. Since the 1650 eruption, the chamber has expanded at an average of about 4 million cubic meters, 141 million cubic feet per year, every year, without interruption. If that rate continues, within roughly 150 years, the system could contain about 2 cubic kilometers, half a cubic mile, of magma. That figure closely matches the estimated volume released during the 1650 eruption. In practical terms, the volcano is gradually recharging. Researchers emphasize that Kolumbo's structure suggests the potential for a highly explosive eruption, similar in style, though smaller in magnitude, to the 2022 Hunga-Tonga eruption in the Pacific, which generated tsunami waves up to 20 meters high and sent ash into the stratosphere. Kolumbo lies only 7 kilometers from Santorini, an island with about 20,000 permanent residents and more than 3 million tourists annually. In January 2025, seismic activity intensified. On January 27th, an earthquake swarm began approximately 10 kilometers northeast of Santorini, directly within the Kolumbo region. Over about 30 days, more than 30,000 earthquakes were recorded between Santorini and Amorgos. The University of Athens documented over 15,000 tremors in just 15 days, a level of seismic concentration not previously recorded there. The largest earthquake reached magnitude 5.2. A state of emergency was declared between February 6th and March 3rd, 2025. Schools closed. Residents drained swimming pools to reduce structural stress caused by water movement. Approximately 11,000 people left the island voluntarily. In November 2025, a study published in Nature revealed that Santorini and Kolumbo are connected through a shared deep magmatic system. Data indicated that inflation beneath Santorini's caldera began in mid-2024 and was followed by the intrusion of a magma-filled dike sourced from beneath Kolumbo. Two volcanic systems separated by only 7 kilometers, supplied by the same deep reservoir. Researchers analyzed more than 25,000 earthquakes using artificial intelligence and determined that magma propagated through the crust at depths exceeding 10 kilometers across an area of roughly 20 kilometers. Although the magma did not reach the surface, scientists warned that this interaction increases the probability of future activity. During the seismic crisis, the seafloor above Kolumbo subsided by up to 32 centimeters, while parts of Santorini rose by more than 10 centimeters. These measurements indicate magma redistribution between the two systems in real time. It was not random movement, it was structural adjustment within a shared magmatic engine. Volcanoes do not operate on human timelines. 400 years feels long to us, but to a magmatic system, it can represent a single recharge cycle. Kolumbo's chamber has been growing year after year through generations, through wars, technological revolutions, and the entire modern tourism era, all while remaining invisible beneath the sea. Submarine volcanoes behave differently from land volcanoes. When rising magma interacts with seawater, it can trigger violent steam-driven explosions. Water flashes into vapor almost instantly, expanding with enormous force. The rapid expansion fragments magma into ash and gas, increasing explosivity. Historical accounts from 1650 described boiling seas, drifting ash, and toxic gas. The geography has not changed, but exposure has. Kolumbo is positioned inside a semi-enclosed basin. That means any explosive event would occur close to surrounding coastlines. Tsunami modeling suggests that even moderate seafloor displacement or flank instability could push waves outward rapidly. In confined basins like the Aegean, waves do not need to travel far to reach land. Farther west in the Tyrrhenian Sea lies Marseille, one of Europe's largest submarine volcanoes. Stretching approximately 70 kilometers long and 30 kilometers wide, it rises nearly 3,000 meters from the seafloor, with its summit about 450 meters below the surface. The Italian National Institute of Geophysics and Volcanology has warned that Marseille's flanks are structurally unstable and supported by a shallow magma chamber. Simulations from the University of Bologna suggest that in a partial flank collapse scenario, tsunami waves could reach the Aeolian Islands within 10 minutes and the coasts of Calabria and Sicily within about 20 minutes. In extreme cases, wave heights could approach 20 meters. The Mediterranean lacks the extensive tsunami early warning systems present in the Pacific, and distances between sources and coastlines are short. However, monitoring efforts have intensified significantly. In December 2025, the research vessel Meteor launched the Multimar expedition to test advanced submarine monitoring systems near Santorini. Kolumbo has been under continuous observation since 2022, and additional seismographs were installed within its crater during the 2025 swarm. Ocean bottom seismology, satellite radar interferometry, AI-assisted earthquake analysis, and high-resolution acoustic imaging have transformed how these systems are understood. Santorini and Kolumbo are no longer evaluated as isolated cones, but as components of a broader interconnected magmatic system. Volcanic systems can experience significant unrest without erupting, and monitoring agencies continue to assess data carefully. But what is clear is that the Mediterranean is not geologically quiet. It is dynamic beneath the water. The calm blue surface above Santorini hides a magmatic system that has been building for centuries. It is measurable. It is evolving. And for the first time in history, humanity has the tools to observe it in detail. What happens next will be determined not by speculation, but by physics, pressure, and time. And scientists will continue tracking every seismic shift, every deformation signal, and every new study that sheds light on what lies beneath the sea.